Yeah, so for these two questions, so that is 66 and 67 question, so you can go back and check. Already I have made a video on 68th question, right, the last question from capacitors chapter. So here already I have derived the value of force, so I'm just using the same value, okay, the same value to solve this both the questions. So that is 66 and 67. So if you want, you can go back and check that video that I have made on the 68th question. So very detailedly I explained the like whole scenario, what happens and how it is working. So in that case we have derived the value of what, the force that is exerted by the capacitor on the what, dielectric slab. So that force I will be using over here. So this is the force value that we have got, right? So this is the force value. So just this is the like important formula that you should be knowing, or like you can derive the way that I have told. So by using this formula I can just solve these two questions very easily with one step. So in this question, so they are telling that this slab should be remaining in what, equilibrium. So when this can remain in equilibrium, obviously this exert a force right side, this capacitor will try to pull the dielectric right side, and this capacitor will try to pull this capacitor what, left side, with force F1, right? And this is, let's say, EMF E1, and this should be what, EMF E2. So they're telling that it should remain in what, equilibrium. So equilibrium means what, net force should be zero. So net force zero means what? So what does net force zero means? Net force zero means, so like simply F1 should be equal to what, F2. So obviously both F1 and F2 must be what, equal. So let us just equate the value of F1 and F2. So F1 must be equal to what, F2. So area of the plates so both are yes, identical. Let me check a shape with length B and lengths of what, L1 and L2. So basically I can take area, the area of the plate same. Let me check. Shows two plates of the area with fixed plates connected to two batteries. Okay, separation between the plates is same, that means D is same for both the things. And the plates are rectangular shape of breadth B. So inside there is a B and length is what, L1. So B and this is L1. Okay, fine. So that means area should be replaced with what? Area should be replaced with B into length L. So then LL will get cancelled. So we'll just remain with what? B. So the same formula can be replaced with what? B epsilon naught E square by 2D into K minus 1. So therefore force F1 can be written as what? As I said, this A is the area of the plate. Here area of the plate can be written as what? This width B multiplied by this length what, L1. So that will be the area. So here width B multiplied by length what, L2. So therefore B epsilon naught E1 square by what, 2D, because LL got cancelled, into K1 minus 1, which must be equal to B epsilon naught E2 square by 2D into what, into K2 minus K1, sorry, K2 minus K minus 1, right, K2 minus 1. So now, so what are the things you can cancel? B epsilon naught 2D, so B epsilon naught 2D will get cancelled. So therefore from here I can write the value of, they're asking, what they're asking, the ratio of EMF of the left battery to the right battery. So therefore E1 by E2 is nothing but what, so it is square is there, so if you take other side it will become under root of K2 minus 1 by K1 minus 1. Okay, so I hope it is clear. So it's very simple, we just need to use the result that we have got. So already I have derived a result, right, that force acting on the dielectric slab will be independent of how much length it is inside, right? So here they haven't even mentioned what length is inside. Okay, so very clearly explained in the last problem, that is 68th problem. So you can clearly see that force on the slab is independent of the length of the slab inside of the capacitor, right? So if you just go back and check that 68th question, so very clearly explained in that question. Okay, so I just used that formula and got the answer, and same formula you need to use over here. So again here they are telling that the system should remain in what, equilibrium. So now here we know that left side it will be pulled left side with, let's say, force F, that is electrostatic force, and right side T is there, and here for this T will be there, and down what will be there, mg will be there. So we know that for equilibrium, what should happen? For equilibrium, net force should be what? 0. For equilibrium, net force should be 0. That means for the net force to be 0, F equal to what? T. But T already we know that T is nothing but what? T equal to mg. T is equal to what? mg. So therefore you just replace force with what value? Again here also area is not given, width is given, length is given. So again if you just replace A with BL, so LL will get cancelled. So what will you get? B epsilon naught E square by 2D into K minus 1, which is equal to mg. So therefore our mass m is simply can be written as what? B epsilon naught E square into K minus 1 by 2dg. So this will be the value of mass that is required, so to keep the system in equilibrium. Okay, so these two questions are pretty much easy. So like if you know the formula that I have derived, okay, so the same thing, let's say, sir, what if this question is given, okay, like without solve, like let's say you might be thinking, sir, what we should do means like whatever the formula that I derived, right, that formula you just need to derive. Okay, so the derivation part already I explained over here. So we'll be just writing C as a function of what? C as a function of X you will be writing by taking some distance of the slab is inside the dielectric, and then after knowing the value of C you can find the energy stored in the capacitor, and we know that energy will be stored in the capacitor in the form of what? Electric field, and we know electric field is a what? Conservative field. So whenever we have conservative fields, then we have relation between force and conservative like energy, right? Potential energy that is stored. So that is F equal to minus du by dx. So by using that we have derived that what? The force, right? The same force value I have used, and easily we have solved these two questions, right? So after you know that formula, there is nothing in these two questions. They are pretty much simple. Only note point that you need to know is that force is independent of like whatever the length of the slab that is there inside the capacitor. Okay, so I hope it is clear. Yeah, thank you.